All right, hey 6A, we are going to be jumping back now in our packet to some concepts that we learned all the way back at the beginning of the school year. Back in Module 1, we talked about ratios, and that's what we're going back to now is we're going to talk about ratios, unit rates, unit conversions, percents. I know it's been a while since we've done any of that, but it's definitely something we need to go over again. So we are first going to be taking a look at equivalent ratios. This was one of the very first things that we did in Module 1 of our Eureka books. So we know that equivalent, right, means that they are equal, right? We've talked about that part of equivalent means that we have some things that are equal to each other, maybe the same, equal in value to one another. But before we even go there, let's talk about what is a ratio. So I want you to pause the video and think about what is a ratio. And hopefully you paused and thought about it. So a ratio, if you remember, is we're comparing two or more things, right? So we have two different values of something, and we're looking at how do those compare to one another. So for example, if you remember, we can write ratios with our colon. We can also write ratios as a fraction, right? I could write this ratio of 3 to 2 as 3 to 2. Okay, that's the value of the ratio, right? The value of the ratio 3 to 2 is 2 halves. We could also actually write this out as 3 to 2, right? Those are lots of different ways that we could write a ratio. So we're starting with this one. Now, if I want to know what they're equivalent to, a ratio that's equivalent means the way that we need to keep them equivalent is if we are multiplying or dividing each part of my ratio, right? So my 3 and my 2 by the exact same number. So for example, if I have a 6 here in this second ratio and I'm trying to create an equivalent ratio, right? And I want to know what number goes in that second spot. Well, I know that my first number goes with my first number, right? So my 3 goes with the 6, right? My first number. So I ask myself, how do I get from 3 to 6? If they're equivalent, I need to multiply or divide by some number. Well, I know that 3 times 2 equals 6. So now I'm going to take a look at the second number. If they are equivalent, then I need to multiply again by the same number. So I'm also going to multiply that times 2. Well, I know that 2 times 2 gives me 4. So 6 to 4 is an equivalent ratio of 3 to 2. So I want you to pause the video and I want you to tell me with each of these examples what number goes in the blank spot here. So in this box here and in this box here. So hopefully you've paused. What we're going to see here is I know that to get from 7 to 28, I multiply by 4. So for them to be equivalent, I need to multiply by 4. 4 times 4 gives me 16, okay? For this next one, see that I'm looking at the value of the ratio. So here, I wanna know what the value of the ratio is. This ratio that we're given is 30 to 10. We can see that in the value, 30 to 10. So I know that now I'm going from 10 to 1. Well, if I multiply, my numbers get bigger, but I want my number to get smaller. So now I'm actually dividing. 10 divided by 10 gives me 1. So that means I also need to divide my numerator by 10, and I know 30 divided by 10 is 3, okay? So the equivalent ratio is 3 to 1, or in this case, they're both written as fractions. This is the same way that you would simplify a fraction. You multiply or divide the numerator and denominator by the exact same number. Okay, so that's where we're at with equivalent ratios. The last thing I want to do is show you how we can see some equivalent ratios. In your packet on page number 13, you see that we can look at equivalent ratios as coordinates on a coordinate plane. So if I look, for example, at this point right here, the coordinates are 2 and 6, right? So that would be the same as a ratio of 2, if I look down here, 2 steps is a 2 to 6 feet, right? So my ratio is 2 steps to 6 feet. If you read the context of this question, it'll make a little bit more sense, right? So another equivalent ratio would be any of these points that are on my graph. And you'll see that they all, when they're equivalent, they all are in this straight line because they all are actually going up by the same number of steps and the same number of feet each time, right? From every point, we're going over 2 boxes and up 2 boxes every time, over 2 and up 2, over 2 and up 2. And we're going to look a lot more at the coordinate plane with this when you get into 7th grade for sure. Okay, so you might see some equivalent ratios on a coordinate plane like this. Okay, and then also another way, actually let's keep with the same problem. Another way that you might see your equivalent ratios is in a ratio table. So in this case, I'm just going to say X and Y since we are using a coordinate plane. You could also put steps to feet, right? That's another way that we can look at this ratio. We talked about ratio tables a lot, right? Where if I take 2 steps, then I know that I'm going 6 feet, right? Another point from my table or from my graph, 4 steps is going to be 12 feet. 6 steps is going to be 18 feet. We use these ratio tables a lot because there's 2 different relationships that we see. We can find some equivalent ratios by seeing, well, every time that I go up 2 steps, I'm also going up 6 feet. If I go up 2 steps, then I'm going up another 6 feet, right? So then I could find my next row by saying, well, if I add 2 more steps to get 8, then I can add 6 more feet to get 24, right? So you can add 2, add 6, right? And we can keep adding that additive relationship in our table, but you can also see that there's a multiplicative relationship. Every single time in my ratio table, I'm multiplying by 3, right? 2 times 3 is 6, 4 times 3 is 12, 6 times 3 is 18, and this is always going to be true for ratios. They are always going to have a multiplicative relationship. And actually, even if you look at it going up 6 feet to 2 steps, if we simplify that, 6 divided by 2 is 3. So when I am going up on, whenever I'm adding on the sides, right, when I divide those, even finding the ratio of what I'm adding on each side is going to give me that multiplicative relationship. And that's something that we talked a lot about in Module 1. So hopefully this is helpful. You can find some equivalent ratios. The biggest thing to remember is that for equivalent ratios, I need to multiply or divide both parts of my ratio by the exact same number. They cannot be different. So hopefully this is helpful.